Welcome back. Now, we're gaining experience, and we made a level up function, which currently does nothing, but we'll fill that in with functionality. But we currently don't know when we should level up. That's something we should figure out. So I'm going to close the editor. I'm going to go to my Aura attribute set and close all other tabs. And right here in Post Gameplay Effect Execute, as we're checking the incoming XP, we have a to-do to check to see if we should level up. So we have to decide if we should level up, and we're going to do that inside of our if statement once we know that our source character implements the player interface. Because if the source character doesn't implement the player interface, there's no point, as my enemies aren't going to level up. In your game, that might be different. You may wish to level up your enemies, which would require a minor adjustment. But I would like my enemies to not level up, so only my character. And for incoming XP, that's going to be the source character, as the source character is the one applying the gameplay effect. Remember, we have a passive gameplay ability with a gameplay effect, and we're applying the spec to self. In case this might be something you may be confused with, I'm just going to clarify that in a comment here. We're going to say source character is the owner, since GA listen for events applies GE event based effect adding to incoming XP. So this just makes it clear in case we get confused. All right, so how do we check to see if we should level up? Well, I'm going to check before we add to our XP. We want to add to our XP regardless, but I want to know if a level up is in order. Now, in order to check to see if we should level up, we need to know our current level. So I'm going to make a const int32 called current level, and we're going to use iCombat interface and call execute get player level, passing in props.sourceCharacter. Now we have our current level. I'd also like to get our current XP, so I'm going to make a const int32 called current XP as well. And for this, we need to get our XP. Now, how do we get our XP? What's an easy way to do it? Because our XP exists on the player state, right? And we can't really just dig into the player state. The player state already depends on Aura attribute set. We don't want a circular dependency. Let's take a look at what our player interface has. Oh, look at this. We have an add to XP. We could easily have a get XP. That's what I'd like to do. So let's make a getter for our XP. I'm just going to copy add to XP and paste up here and change this from a void function to an int32 returning function called getXP. It does not need to take any input parameters. It can even be const. So now that we have this Blueprint native event, we can override the implementation version of it in Aura character. So let's go to Aura character and implement it. Here in the player interface, looks like my comment says players interface. I'm going to change that to player interface, and we're going to override virtual int32 get XP implementation. And this will be pretty simple. We're going to generate the definition and get our player state, just like we did in get player level implementation. And after checking the player state, we're going to get Aura player state and call get XP. And this is what we can return from the function. So now we have get XP implementation. So back in Aura attribute set, we can call that player interface, execute get XP, passing in props.sourceCharacter. Now, I just noticed we're checking if we implement player interface. We're not checking for combat interface. We know that if we implement player interface, we definitely do implement combat interface because players and enemies both implement it, but we could just place a check here just to show that we care about checking. So we're going to say props.sourceCharacter implements, and we can use combat interface as well. Okay, so once we have our current level and current XP, what we should do is we should see what level corresponds to our new XP amount. In other words, if we take our current XP and we add this incoming XP to it, what level would that correspond to? In other words, if we make a const int32 called new level, what would that be? Well, we have the capability to find that out because we created a data asset that can do that. If we go into our public folder, into Ability System, Data, and find level up info, we have this, find level for XP. Now, our level up info exists on our player state. If we go to player or a player state, we have that level up info data asset right here. And once again, Aura attribute set does not depend on the player state. So what we can do is just make a function on our interface for performing that lookup. We can go into interaction, player interface, and just create a function that can do this for us. So we can call this function find level for XP. It can take an int32 called inXP. It can also be const. And we can implement this in Aura character. So virtual int32, find level for XP implementation, and we can go ahead and generate the definition. We can get our Aura player state. So copying that from getXP implementation. After we get our Aura player state, we can take Aura player state, get level up info, and we can call find level for XP, passing in inXP, and we can return this value. And now we have an interface function we can call in Aura attribute set. So new level is going to be iPlayer interface, execute, find level for XP. Now we want to find the new level, the level for the amount of XP that we would have after adding incoming XP to current XP. So the amount we're going to pass in here is current XP plus our local incoming XP. And of course, the first input has to be props.sourceCharacter, doesn't it? So first we pass in the source character, then we pass in the int32. So this is the new amount of XP that we're going to add to our XP. So now that we know the new level, this is how we're going to know if we should level up, because we know our current level and the new level that corresponds to our new amount of XP that we're about to have. We can take the difference between these, and that will tell us how many times we should level up. So we can make a const int32 called number of level ups, or even just num level ups. And that's equal to new level minus current level. Now, if we call this function with not enough XP to level up, let's say we were at 100 and we only went up to 120, we need 300 to go up to level 2. Well, this will return the same level that we're at, which would be 1, and new level minus current level would be 0, so the number of times we leveled up was 0. So we know based on this value if we leveled up or not. It's if this value is greater than 0. So we can say if num level ups, oops, writer auto-completed and auto-included something for me. Looks like I have several dead includes that I can remove here. I don't need gameplay statics currently. I don't need Aura log channels, and I don't need this header that was just auto-included. So, all right, back to what I was doing though. We need to check num level ups. And if that's greater than 0, we're leveling up. Potentially multiple times, right? So what do we do in that case? Well, for one, we can call our character's level up function. So we can take iPlayer interface, execute level up, passing in props.sourceCharacter. That's one thing. That function's currently empty and doesn't do anything. But since we're leveling up, we can call that. And then we can do any other mathematical perks that we want. For one, we're going to have an attribute point reward and a spell point reward. We're also going to add to our player level on our player state. We're going to add to all of those things. So what I'd like to do is, first of all, get our level up info to tell us what our attribute point and spell point rewards are. Let's make a to-do here. We'll say get attribute points reward and spell points reward. And we'll continue this comment and say add to player level. We'll have another one to add to attribute points and spell points. And we also need to add to XP, but we're doing that already. So that's taken care of, but we want to add to player level, attribute points, and spell points. And of course, execute level up. Now, when we level up, we typically fill up the health and mana, so we'll also say fill up health and mana. So quite a few things to do when we level up, right? Now, if we want to get our attribute points reward and spell points reward, those exist on level up info, which exists on the player state. So these would be good interface functions to have. Adding to the player level, attribute points, spell points, all of that stuff is also stuff that requires the player state. So we need functions on our player interface for all of these. In other words, get attribute points reward and get spell points reward should be functions. So in our to-do, I'm just going to list the functions we need to make. Get attribute points reward. I'm just going to say we need to make that function. Get spell points reward. I'm going to say that we need that. Add to player level. That should be a function. Add to player level. And then, of course, add to attribute points, add to spell points. So we'll say add to attribute points. Add to spell points. So these can all be functions on our player interface. So let's start at the top. We need get attribute points and spell points rewards. We'll go into player interface and make getters for those. I'm going to put all my getters together. So I'm going to put it right under get XP. So this will be an int32, not 43, 32, called get attribute points reward. And it can be const. So I'd like this to be a Blueprint native event. I'd also like the spell points version of this. So I'm going to copy and paste it. And this one will be get spell points reward. So we're going to have to implement those. But I'm going to go ahead and declare all the functions we should implement. So we got these two. We need add to player level and the add to attribute points and spell points. Let's declare those. So just after add to XP, we're going to have 3 more. We'll start with add to player level. We'll call the input in player level. And then we'll have add to attribute points. And the input will be in attribute points. And we'll have an add to spell points. So we'll call this add to spell points. And the input will be called in spell points. Okay, so we have a number of functions we should implement the implementation versions of in Aura character. That'll be here in the player interface. So I can look at my comment here. We have get attribute points reward. Let's implement that. So virtual int32, get attribute points reward implementation. Next we have get spell points reward. Virtual int32, get spell points reward implementation. Next we have add to player level, add to attribute points, add to spell points. So we have virtual void add to player level, virtual void add to spell points, and add to attribute points. I'm going to put that one first after fixing my typo. So virtual void add to attribute points. All right, let's get those definitions generated. And these are going to all just get our Aura player state. So I'm going to get those two lines. And then get attribute points reward is going to return Aura player state, level up info, level up information, and we actually need to know the level to get the attribute points reward, don't we? So get attribute points reward and spell points reward need to take in an int32 for the level. So let's do that. We'll go back to the player interface. Get attribute points reward needs to take in an int32 called level. Get spell points reward needs an int32 called level as well. So we'll fix that. We'll go to Aura character and make sure these two functions take int32s. And then back in the CPP file, we'll make sure that they take int32s. And level up information can be indexed at level. We can use dot and get attribute point reward. So this will be similar in get spell point reward. We're going to paste that all. The only difference is we're going to get our spell point reward instead for that level. Now for add to player level, this is going to get our Aura player state, and we're going to add to the player level, and Aura player state has add to level, so we can handle that here. So first we're going to get Aura player state, take Aura player state, and call add to level. And of course, this cannot be const if we're going to call add to level. And we're going to pass in player level. Really, this should be called in level amount to add or something like that. But add to implies that, well, we're adding to the level. Now, add to attribute points and add to spell points. Let's see if we had created those. We don't have add to attribute points or spell points. In fact, our Aura player state doesn't have attribute points and spell points. So we'll go ahead and create those later. And for now, we'll just put a to-do on these. We'll say comment to-do, add attribute points to player state. I'd like those to be variables on the player state. We'll do the same thing for to-do, add spell points to player state. So only so much we can do all at once. We can't go on too many tangents right now. For now, though, we have these interface functions and they're implemented. So back in attribute set, we can take care of this to do. So we created get attribute points reward and spell points rewards. We can get those. So we can say int32 attribute points reward. And we can use iPlayer interface. Execute get attribute points reward, passing in props dot source character, and we can pass in the level for the attribute points reward. So for each level in our data asset, we put an attribute points reward for leveling up at that level, so we can pass in our current level here, and that can be const. We can also make a const int32 called spell points reward, and we can use iPlayer interface, execute, get spell points reward, passing in both props.source character and current level here as well. Now that we have those, we can do these other things like add to player level. So we can take our iPlayer interface and execute add to player level. So first we pass in props.source character, and we want to add to the current level. How much? Well, the number of level ups. So num level ups. So that takes care of that to do. And then we want to add to our attribute points and spell points. And again, our Aura character doesn't do anything for this yet, but we'll go ahead and call those functions. So we'll say iPlayer interface, execute, add to attribute points, and we're going to go ahead and pass in props.source character. And how much do we want to add to our attribute points? We want to add our attribute points reward that we looked up. And then we can take iPlayer interface and execute, add to spell points. And again, we're going to pass in props.sourceCharacter and our spell points reward. So that takes care of those. Now we can fill up our health and mana, and that is actually something we already can do from here. We can just call set health, and we can set it to the max health. Get max health, like so, and we can set mana to its max as well. Set mana to get max mana. That way we're all filled up, we're topped off, our health and mana globes will be filled. So now we're handling all the level up stuff. So we don't need this to do to see if we should level up. Now post gameplay effect execute is looking a little unruly, so we could really refactor these into each their own functions. That's fine for now. We'll refactor it in a little bit because this video is getting long, but at least now we're executing this level up capability. And really all we're doing here is executing these interface functions, and Aura Character implements them such that we're calling functions on the player state, such as add to player level. So we're going to want to show our player level in the HUD, and our player state, if we go to Aura Player State and take a look at its add to player level and other add to functions, we're broadcasting delegates. So it's already set up so that once we add to the player level, those delegates will be broadcast, and then we can very easily respond to these in our widget controller, and therefore our widgets. So this is a great stopping point. Let's just compile, make sure that there's no compiler errors we might have missed. And with a successful compile, we'll continue in the next video. I'll see you soon.